Okay. Good afternoon to all. So I think last lecture. Am I audible clearly? Is screen visible? Okay. Once again. Okay. So good afternoon once again. So last lecture we have started our unit number 5. That is the first unit of second section. That is steam nozzles, one of the important part of the vapor power cycle. It is integrated part of the steam turbine. Okay. So nozzle, who will define nozzle? Anybody of you? Last time only we have defined nozzle. Nozzle means what? Anybody of you?
It converts thermal energy of steam into kinetic energy of steam by increasing velocity.
Okay, so it is a one device or device which converts thermal energy of the steam into kinetic energy, means by increasing the velocity. Kinetic energy means increasing velocity, and these nozzles, steam nozzles are there. So expansion, whatever the expansion of the steam is taking place, it is taking place in nozzle only. Okay, so whatever isentropic expansion we are assuming in the vapor power cycle, it is in the turbine. Actually, it happens in the steam nozzle. Okay. Then after we have discussed about the types of nozzles. So which are the types of nozzle? Anybody of you? Already on the screen, one nozzle is there. Anybody of you can define types of nozzle? Convergent nozzle. Okay, Asmita.
Divergent
and
convergent divergent.
Okay. Convergent means the cross sectional area is goes on here decreasing towards exit, okay, or towards outlet. So that kind of nozzle we call it as a here convergent type of nozzle. So area is continuously goes on decreasing, varying. All the nozzles are of varying cross section. So area is goes on decreasing towards outlet. So that type kind of nozzle we call it as a convergent nozzle, and it is used when here back pressure is greater than or equal to the critical pressure. What is critical pressure ratio? Anybody? Other than Asmita, if somebody is explaining, then I will be happy. Okay, so critical pressure means what? What is called as critical pressure or critical pressure ratio? Anybody? Chart box or okay. Then Asmita, you can critical pressure.
It is the pressure ratio which gives maximum flow rate through nozzle.
Maximum mass flow rate through the nozzle. That is called as what? Critical pressure ratio. Then divergent type of nozzle is there. It is one kind of nozzle where cross sectional area is goes on increasing towards outlet. Okay, and it is used when back pressure is less than the critical pressure. And but frequently, more frequently, we are using this convergent divergent type of nozzle. And what is happens in the convergent divergent nozzle? Anybody? What is say here convergent divergent nozzle? It is combination of both convergent and divergent nozzles. So inlet part is consisting of convergent part, then diameter or that area of cross section become very smaller, and then afterwards it goes on increasing. It is called as divergent part. Okay. So convergent divergent nozzle. So and where the area is very less, that part or diameter of that nozzle is very less. That part we called as a anybody. So this is convergent part. So frequently used nozzle is a convergent divergent type of nozzle. Okay. So convergent section is there. It is convergent inlet. Okay. And this part is there. Where the cross section area is very minimum. That part we called as a
throat.
THROAT throat. Okay. So it is here throat is there, and this type of nozzle is used in all in the industry or maximum types. Frequently, this kind of convergent divergent type of nozzle is used frequently. The first inlet is convergent section and outlet is divergent section. Okay. So it is when back pressure is less than the critical pressure. Then flow of steam through nozzle. We have assumed that whatever the expansion we are assuming, that is here expansion of steam. The expansion of steam through nozzle is considered as adiabatic, or we can say it as a isentropic. So whatever the expansion we have assumed in our steam turbine, so that expansion actually happens in the nozzle, and that expansion takes place from high pressure, that is boiler pressure. Whatever the steam is coming from boiler into nozzle, so boiler pressure to the condenser pressure. So that expansion is taking place in case of here in the nozzle, and that we are considering in the turbine, but actually it happens in the nozzle. So the high pressure, high temperature steam is expanding, so the pressure is goes on decreasing. At the same time, enthalpy, because turbine is developing work, enthalpy also goes on decreasing. So HS diagram, if you can say 1 to 2, enthalpy drop takes place. And what are the enthalpy drop takes place? It is nothing but increased velocity in the nozzle. Okay. After that that nozzle, that kinetic energy will be converted into mechanical work. But up till now, we have to limited up to what the thermal energy change, heat drop is taking place into kinetic energy. Therefore, we are here kinetic energy is increasing and thermal energy is converting into kinetic energy. So how we are converting that is total energy of steam. So as expansion is adiabatic, we are not supplying any kind of heat, or no heat is rejected through the expansion. Okay, and due to that, what will happen? So enthalpy is there. Whatever the total energy of the steam is there before expansion, okay, or at inlet is equal to at outlet. After expansion is at outlet. Okay, so therefore we are assuming that H is equal to PV. So pressure and volume energy is nothing but what it is included, everything included in the specific enthalpy H. Okay, H1. So we are assuming that H1 is going to be inlet parameters were we are denoting by suffix 1, and outlet parameters were denoting by suffix 2. Okay, so total energy of the steam at inlet of nozzle is equal to your enthalpy, specific enthalpy plus pressure plus kinetic energy. So it is having some kinetic energy. So H1 plus C1 square divided by 2 is equal to total energy of steam at outlet. Enthalpy is decreasing, but kinetic energy is increasing. So AC2 square divided by 2. And where we are assuming it is very important, that is H1 is specific enthalpy in kilojoule per kg. C1 is in meter per second. Okay, velocity of steam at inlet. H2 is also in kilojoule per kg. C2 is also in meter per second. Okay, then both energies we want kinetic energy change. Therefore, C2 square minus C1 square divided by 2 is equal to H1 minus H2. But as this is in kilojoule per kg and this is meter per kg, meter per second, so bringing them in yeah, only one unit, what we are to do is we have to convert this kilojoule per kg into joule per kg, and for that we have to multiply it by 1000. Therefore, equations is not visible. Okay. Thank you, Jagannath. Thank you. Thank you. Now, is it visible? Is it visible now? Okay, thank you. Okay, 1 minute. Start right. Okay. So once again, I will repeat. So total energy at inlet is equal to total energy at outlet, and suffix 1 we are representing by for inlet and suffix 2 represented for outlet or exit. Therefore, total energy of steam at inlet of nozzle is equal to total energy of steam at outlet of nozzle. Therefore, H1 plus C1 square divided by 2. H1 is what? It is a specific enthalpy or heat energy plus C1 square divided by 2. It is kinetic energy is equal to H2 plus C2 square divided by 2. Okay, where H1 is specific enthalpy of steam at inlet, C1 is velocity of steam at inlet. Okay, then C2, remember that C1 and C2 should be in meter per second and H1 and H2 should be in kilojoule per kg. And therefore, C2 square minus C1 square divided by 2 is equal to H1 minus H2. And but this is in kilojoule per kg and this is in meter per second. So bringing them in same unit, okay, in as per dimension analysis. So what we have to do is this H1 minus H2 we have to make in joule per kg. Okay, and for that it should be multiplied by 1000. So T2 square minus C1 square divided by 2 is equal to 1000 into H1 minus H2. Okay, therefore C2 square minus C1 square is equal to this 2 into 1000 is equal to 2000 into H1 minus H2. Okay, therefore C2 square is equal to, we are interested in exit velocity. Okay, so C2 square is equal to 2000 into H1 minus H2 plus C1 square, or C2 is equal to square root of 2000 into H1 minus H2 plus C1 square. Okay, and this H1 minus H2 we can call it as a enthalpy drop also. So if initial velocity of the steam is given, then this formula we have to use. Otherwise, we have to use here if exit velocity is not given at inlet, sometimes because C2 is too much times greater than C1 because it is exit velocity and C1 is very, very small as compared to C2. Therefore, initial velocity of steam is very, very less as compared to exit velocity of steam. Hence neglecting C1. Neglecting C1 is considering it as a 0 as compared to C2. So C1 is equal to 0. Therefore, C2 square is equal to square root of 2000 into HD, or HD is equal to H1 minus H2. And square root of 2000 will be 44.72 into HD. But here C2 should be in meter per second and HD or H1 minus H2 should be in kilojoule per kg. Up to that, I think we have completed last lecture. Then flow of steam considering the friction. We are considering friction. So actual expansion of steam through nozzle is what? Here it is going to be not isentropic. Because of the friction, the process will become irreversible. So isentropic means reversible adiabatic. So the process will not be reversible. Okay, because of the friction, the process will be, it is irreversible. And due to the we know that into the irreversible process, here entropy always goes on increasing. So we have to draw the sketch of a chess diagram, okay, specific enthalpy versus entropy diagram. Okay, this is in kilojoule per kg, this is kilojoule per kg Kelvin. So this is going to be our saturated curve, and only expansion we are considering. So this is boiler pressure, okay, this is condenser pressure, and this is ideal expansion 1 to 2 from boiler pressure to condenser pressure. But we know that expansion is not isentropic, it is anisentropic. Therefore, the entropy is increasing because here, therefore, it is 2 dash point will come at the right RHS side of the 2. Therefore, 2 dash will come. This is and H1 minus H2 dash. This is the enthalpy drop. Actual enthalpy drop H1 minus H2 dash. Okay, and is smaller than theoretical enthalpy drop H1 minus H2. Means actual exit velocity will be also lesser because actual exit velocity is depends. The exit velocity depends on here H1 minus H2 exit here enthalpy drop. Okay, therefore friction exists between the nozzle surface and steam, and due to this, some of the enthalpy of steam, some of the enthalpy drop of the steam decreases. Okay, and due to that, what will happen? Enthalpy is goes on. Specific enthalpy due to friction increases. Entropy also goes on increases. Okay, available energy goes on decreasing. Available energy is H1 minus H2, and actual enthalpy drop becomes smaller than the theoretical enthalpy drop. And here actual enthalpy, therefore we have to define the nozzle efficiency, and it is denoted by letter K. Okay, K, and nozzle efficiency defined as ratio of actual enthalpy drop, because it is always ratio of smaller quantity to larger quantity. So nozzle efficiency defined as ratio of actual enthalpy drop in the nozzle to the theoretical enthalpy drop. Therefore, K is equal to actual enthalpy drop H1 minus H2 dash divided by your theoretical enthalpy drop H1 minus H2, or H1 minus H2 dash will become K into H1 minus H2. And again, if you want to calculate the actual exit velocity, so what we have to do is, here the actual exit velocity of neglecting initial velocity is given by C2 dash is equal to same C1 square we have to consider as a 0. Okay, therefore C2 square is C2 dash is equal to square root of 2000 into actual enthalpy drop HD dash. Okay, therefore HD dash is equal to H1 minus H2 dash, but we know that H1 minus H2 dash is equal to K into H1 minus H2, or C2 dash is equal to 44.72 into square root of K into HD. Okay, HD means it is theoretical enthalpy drop, or C2 dash is equal to 44.72 into K into H1 minus H2, H2 only, not H2 dash. Okay, this is going to be the equation. Nozzle efficiency, if losses are given in the sometimes instead of giving the nozzle efficiency, if losses, they will give percentage of losses. So if losses are 20%, then what will be nozzle efficiency? So 20% if the losses will be there, then how much nozzle efficiency will be there? Anybody of you?
0.80.
0.80, and it is, if it is 15, then 0.85. So we have to sometimes they will give nozzle efficiency directly, sometimes they will give losses in percentage. So losses in the percentage, if it is given, then 1 minus that per losses percentage, that will be the nozzle efficiency. Okay, so then afterwards we have discussed about the discharge, that also we have started derivation. So discharge through the nozzle and condition for maximum discharge. So while designing a nozzle, one have to think that it should give the sufficient pressure ratio, okay, sufficient pressure for the flow, and at the same time it should have the sufficient mass flow rate, or it should give maximum mass flow rate at the reasonable pressure. Okay, therefore we are considering the convergent divergent nozzle, convergent part, divergent part. So this is convergent part, and at inlet the property we are considering as the pressure as the P1, specific volume as the V1, and initial velocity is equal to C1. And at throat, where the velocity will be maximum, because pressure is goes on decreasing. So as area is in dynamics, as area is goes on decreasing, pressure is goes on decreasing. In static, it is reverse. Pressure is inversely proportional to area. But in dynamics, pressure is directly proportional to area. So as area is goes on decreasing, pressure is decreasing in throat, but velocity goes on increasing. So whatever the pressure energy is there, it is decrease. It is converting into kinetic energy or velocity energy. So P2 is the pressure of the steam at throat. V2 is specific volume of steam at throat, and C2 is what? There it's velocity of steam at throat. So P1 here we are assumed, and as expansion is adiabatic, what we are assuming. So the law of expansion will be PV raised to n is equal to constant. So now I want to check some revision from your side. So PV raised to n is equal to constant is the law of adiabatic expansion in the nozzle. PV raised to n is equal to constant. So this n value is depends on the type of, anybody?
Quality of steam.
Quality of steam or type of steam. Okay. So if your dry and saturated steam is there, what is the n value is there? N is equal to, anybody MCQ they are going to ask.
1.35.
1.135 for dry and saturated steam, and for superheated steam for
1.35, sir.
1.35. And for the superheated steam,
1.3.
1 is equal to 1.3. And for wet steam, the steam is wet. In equation, which equation we have to use? We have to use the generic equation. What is that generic equation? Anybody of you?
1.035 plus 0.1x.
1.035 plus
0.1x.
0.1 into x. So where x is the drying reaction. With the help of this n values, we have to calculate the values. Okay. So it is correctly 1.135 only. Here it is 1.135. Okay. So n is equal to 1.3 for superheated steam, n is equal to 1.135 for dry and saturated steam, and n is equal to 1.035 plus 0.1 into x for wet steam. Okay. Now this is going to be the adiabatic expansion. So as adiabatic expansion is taking place, therefore work done is equal to gain in kinetic energy. Okay. So because only two changes are there, only here work is done on the nozzle, okay, and is equal to gain in kinetic energy. So for gain in kinetic energy is what? C2 square minus C1 square divided by 2 is equal to work done by steam in nozzle. It is equal to what? It is expansion, therefore, and the work done in adiabatic expansion is given by the formula. If it is adiabatic process is there, PV ratio. Okay, so this is going to be PV. If adiabatic expansion is taking place, then here this work done is given by the formula. So this work done is where this is given by the formula. Anybody? It is n upon n minus 1 P1 V1 minus P2 V2. This is equation we learned in BM. Okay, so this is n upon n minus 1 P1 V1 minus P2 V2. Therefore, as C1 is here, where for simplifying the derivation, we are neglecting C1 because it is very too much smaller than C2. Okay. Therefore, neglecting C1, what we are getting? C2 square divided by 2 is equal to n upon n minus 1 into bracket P1 V1 minus P2. And next, now this is going to be the only understanding. So this is here gain in kinetic energy of steam is equal to work done by steam in the nozzle. This equation, and this is adiabatic law of expansion is PV raised to n is equal to constant, and n values n.1.1, n is equal to 1.3 for superheated steam, n is equal to 1.135 for dry and saturated steam, n is equal to 1.035 plus 0.1 into x for wet steam. Okay. So therefore, C2 square divided by 2 is equal to neglecting C1 is n upon n minus 1 into P1 V1 minus P2 V2. And next are only mathematical adjustments, all complete derivation. Therefore, C2 square divided by 2 is equal to n upon n minus 1 P1 V1 we have taken common. It will become 1 minus P2 V2 divided by P1 V1. But V2 upon V1 we can write in terms of P2 upon P1 as a by PV raised to n is equal to constant. So P1 V1 raised to n is equal to P2 V2 raised to n, and it's simplifying. V2 upon V1 would become P2 upon P1 raised to minus 1 upon n. So in numerical, so afterwards in compressor, all these kind of numericals we have to use, and these formulas we have to use. So V2 upon V1 will become P2 upon P1 raised to minus 1 upon n. Now therefore, putting these values in equation, we have what we are getting. C2 square divided by 2 is equal to n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised into P2 upon P1 raised to minus 1 upon n. So V2 upon n we are putting as a P2 upon P1 raised to minus 1 upon n. And after simplifying, what we are getting? C2 upon C2 square upon 2 is equal to n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to. So this will become what? N minus 1 upon n. Okay. And therefore C2 square is equal to 2n. So these two, if you transfer to this side, it will become 2n divided by n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. Okay. Therefore C2 will become what? Square root of 2n upon n minus 1 P1 V1 into bracket square bracket 1 minus P2 upon P1 raised to n minus 1 upon n. So afterwards simplification, everything is mathematical adjustment, and this is the equation from which equation 5 one can find out velocity of steam at throat. So up to that, we think we have covered. So I have taken half an hour for this revision. So everybody understand last lecture and this revision? Anybody have problem? Please mention, so that we are going to start the new next articles. Understood, sir. Okay, thank you, Smita. Others, please reply. Jagannath also, yes, sir. So Jagannath today, Prerna is there today. Okay, okay, thank you, Prerna. So all Jagannath, yes, okay. Komal also understanding, good Komal. Okay. So discharge through nozzle. Now we have to go for discharge through nozzle. Now discharge is equal to nothing but what? This velocity we got. Now one equation we are knowing, that is equal to your density is equal to mass upon volume. Okay. So this density is equal to sorry, I have muted. Okay. So rho is equal to, once again I will write it. So rho is equal to mass upon volume. Okay. Basically rho is equal to mass upon volume. So therefore mass is equal to rho into volume. Okay. So this is basic equation. So therefore we are interested in discharge or nothing but mass flow rate. Mass flow rate means what? Mass per second, and mass per second is equal to what? Rho into volume per second. So we are divided by second to both sides. Okay. So rho into volume per second, and volume per second will be nothing but what? Rho into area. Volume per second means area into velocity. So volume is nothing but area into velocity means meter per second. So rho into area into velocity. But rho is equal to specific volume, one reciprocal of specific volume. So density is reciprocal of specific volume because it is having unit kg per meter cube. If you go by units, it is easy to understand by units kg per meter cube, and specific volume is having unit meter cube per kg. So therefore, it is density is always reciprocal of specific volume. So therefore, one rho is equal to 1 upon specific volume, and therefore it is equal to area into velocity divided by specific volume V. Okay, so this is going to be the general equation for the mass fluid, and therefore now we are getting the C2 velocity. So velocity at throat. Therefore, here if you know the area at throat A2 and velocity V2, and specific volume will be V2, not V2. It is going to be V2. Then at throat, if we know all the condition, velocity at throat, A2 at throat, V2 at specific volume at throat, then one can calculate the mass fluid. And this mass fluid is remaining constant throughout the nozzle. Therefore, it is always equal to what? M is also equal to, if converging section area A1, velocity will be C1, and specific volume will be V1. So this is equal to, because mass fluid is remaining constant throughout the nozzle. So therefore, but it is equal to M is equal to A1 C1 upon V1, or A1 C1 upon V1 is equal to A2 C2 divided by V2. Therefore, M is equal to mass flow rate, C2 is equal to velocity of steam at throat, and V2 is specific volume of steam at throat. Everybody understand this basic formula? How it comes? This is directly given, it is in books. So I have tried my level best to explain in our language. Okay. Yes, sir. So write down this. So mass flow rate discharge through nozzle is equal to discharge through nozzle at throat is given by, or is equal to same everywhere. So discharge of steam through nozzle at throat is given by M is equal to A2 C2 divided by V2. And in side or somewhere you can write down how it comes derived from our basic. So M is equal to A2 C2 divided by V2. And write down and tell me over this page right up. Because where everybody over others please reply parts that I can have to go to next page. Train no one so it is over. Others please reply, one or two representative if you come. We'll go to next page. So no. Okay. Then see over means others also. Now in this equation now, but substitute the value of C2. What is value of C2? Square root of 2n upon n minus 1 into P1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. So this value we have to put in equation number mass fluid equation. Okay. Therefore, is equal to A2 upon C V2. A2 is area at throat. Okay. A2 upon V2 into C2 is all that equation we have to put 2n upon n minus 1 P1 V1. So all this equation to this value of C2. Okay. So this entire will be C2. Okay. So AR2 upon V2 is equal to here square root of 2n upon n minus 1. This is not required, so if square bracket is not required. 2n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. So this is the value of mass flow rate now becomes. Now here what we're doing is, but at as V2 upon V1 is equal to, so that we are derived in the equation P2 upon P1 raised to minus 1 upon n. So here we want to put V2 is equal to, so all terms we are getting in terms of pressure ratio. Okay, therefore specific volume V2 is equal to V1 into P2 upon P1 raised to minus 1 upon n. Up to this, everybody agree? And this value of V2 we have to put in here equation, this equation or this step. So V2 is equal to what? Here V1 into bracket P2 upon P1 raised to minus 1 upon n. Therefore, M is equal to A2 divided by here V1 into bracket P2 upon P1 raised to minus 1 upon n. Okay. Into here 2 square root of 2n upon n minus 1 into P1 V1 into square bracket 1 minus P2 upon P1 raised to n minus 1 upon n. You would understand? Okay. And this, therefore, this M is equal to A2 V2. Now this P2 upon P1, we have to take inside the bracket, inside the square root. And for that, what we have to do is, if it will go to the numerator side, it will become plus P2 upon P1, or already okay, already you have taken A2 upon V1 is equal to P2 upon P1 raised to 1 upon n into as usual bracket, square root bracket 2n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. Okay. And this value of m is equal to A2 into now there P2 upon P1 if you take inside the bracket, this V1 also we are taking inside the bracket. So this P2 upon P1 will become 2 upon n, because in the square root we have to make it square again, so to make it inside the square root. So this P2 upon P1 raised to 2 upon n, 2n upon n minus 1 P1 V1, and this V1 will become here 1 upon V1 square. Okay, this P2 upon P1 will become 2 upon n into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. Now this 2n upon n minus 1 P1 V1 divided by V1 square into P2 upon P1 raised to 2 upon n. This V1 and this one V1 will get cancelled. Therefore, mass flow rate M will become A2 into square root 2n upon n minus 1 P1 upon V1 into bracket P2 upon P1 raised to 2 upon n, and this this is multiplied inside bracket 2 upon n minus P2 upon P1 raised to n minus 1 upon n plus 2 upon n. This will become A2 into bracket 2n upon n minus 1 into P1 upon V1 into square bracket P2 upon P1 raised to 2 upon n, no problem, minus P2 upon P1 raised to, so this is denominator is same, only addition of numerator n minus 1 upon n minus 1 plus 2, this will equal n plus 1 divided by n. With this is the equation for mass flow rate through the discharge through the nozzle. Understand all steps? It only mathematical adjustment, nothing in that. But we have to remember, we have to make practice and we have to solve. And so I will give some time to you. Understood? Only all are mathematical understand. I have when I was writing on board, I was deriving on board. I have explained everything, and therefore will not like book. So all steps we have written here on this screen or in the notes. So others please reply. Asmita only understanding. Others, Jagannath, Prerna, Please reply fast and write down this. If it is understood, write down. I will give sufficient time to you. So 5 to 10 minutes are sufficient. 10 minutes I will give it to you. Mention understood or not. Please mention and write down all this thing. And write, if your write up is over, mention also. Don't forget to mention completed. Understand and then write. Huh? Don't write only copy. Don't copy. Please mention if it is over. Smita is already over. Oh, quick reply. No. So this is the equation for mass flow rate. Now, from this mass flow rate, we have to derive the condition for maximum discharge. Write down condition for maximum discharge. Condition for maximum discharge. Condition for maximum discharge. So this equation number 2 we are giving Roman 2, and this is equal to what? M into bracket A2 into square root of 2n upon n minus 1 P1 upon V1 into square bracket P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n plus 1 divided by n. Now, in this equation, if you observe carefully this equation, this mass flow rate is very weak. This is constant, so it will not area of the throat will be constant. N it in here it is a adiabatic index. It is depend on the type of steam. So it is whatever the type of steam is entering into the nozzle, it is not the part of nozzle. So this is as per the nozzle. This will be also constant. So because entering steam we cannot decide. So therefore, in this equation, so the specific volume is V1. So it is at entrance. So only thing variable quantity is there. It is P2 upon P1. So pressure ratio P2 upon P1 or value P2 okay, or pressure ratio if we can say P2 upon P1 only it is varying if you observe. Anybody on okay? So the above equation 2 depends only on the variable quantity P2 upon P1. Others will remain as a fixed quantity. So variable quantity is only P2 upon P1. Now, to get the condition of maximum discharge or minimization or optimization condition is that, so whatever the equation is there, this equation we have to find out on which variable it depends. And that equation we have to differentiate with respect to that variable quantity, and we have to differentiate. We have to differentiate with respect to that variable quantity, and that differentiation we have to equal to 0. Okay, so means this condition for optimization. It is a mathematical condition. So hence, to obtain condition for maximum efficiency, differentiating equation mass flow rate equation with respect to P2 upon P1 and equating every differentiation is equal with respect to 0. Everybody understand this part, how to find out condition for maximum discharge? Basic for that is we have to find out the mass flow rate equation on which factor, on which variable it depends. And then after here, condition for maximization or optimization or minimization. Optimization means it may be sometimes maximization or it is sometimes minimization. Or so this condition is that the equation we have to find out on which variable that equation it depends, and that equation, main equation, we have to differentiate with respect to that variable, and that entire differentiation we have to equal to 0. This condition, everybody understand this initial part of the condition of maximum discharge. So this condition henceforth, wherever the we have to go for the condition of maximization, minimization, optimization, we have to use this condition. Not only here, in all subjects. Understood? Write down also this. Understand if you understood, sir. Okay, Smita, I understood. Prerna understood. Others also understanding. Please write up to this and tell me over. Here we'll go step by step because to understand everything. Over, please mention. Now here we have to differentiate this equation with respect to P2 upon P1, and that differentiation we have to equal to 0. Now this is main equation, M equation. So others will remain, only P2 upon P1 will be remaining as a variable quantity. Others, A2 square root 2n P1 upon V1, everything will remain as a constant. Okay. Therefore, this differentiation, this equation where to differentiate with respect to P2 upon P1 only. Therefore, this A2 we have to A2 into square root. Square root differentiation will be what? What is square root differentiation? Will be one of the constant. Okay. So A2 into constant. Okay. Into differentiation of what? Only P2 upon, but this will remain as a constant only. So this bracket only we have to differentiate. Okay. So this, everyone understanding? So this A2 2n upon P1 upon V1. So only pressure ratio is variable. Okay. Others will remain as a constant. So this entire square root differentiation A2 2n upon P1 upon minus 1, everything will be acting as a constant. So constant into d of P of differentiation of equation d of d P2 upon P1 into square root of P2 upon P1, okay, raised to 2 upon n minus, or not square root, sorry, square root also not required. So, or okay, we'll go, okay. So pressure here. So this will be, so up to this will be acting as one of the constant. Okay. So its differentiation will be, this is constant. Okay. And therefore this will be acting as a constant into d of P2 upon P1 into differentiation of means square root quantity P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n upon n plus 1 upon n raised here square root is equal to 0. This condition we got. Okay. Now this constant into this equation, this differentiation will become what? Now this square root will be also one of the constants. And again, this is equal to constant into, therefore, this will, square root will be also one of the constant differentiation. Therefore, constant into 2, yeah, this differentiation will be now 2 upon n into P2 upon P1 raised to 2 upon n minus 1 minus n up plus 1 raised divided by n into P2 upon P1 raised to n plus 1 divided by n minus 1, and is equal to 0. And this constant is equal to 0. Therefore, next step I have cancelled. Constant is into 2 upon n, p2 upon p1 raised to 2 minus n upon n. So this simplification, 2 minus n upon n minus n plus 1 upon n into bracket p2 upon p1 raised to 1 upon n. So n plus 1 minus n. Okay. So this n will get cancelled. This will become what? N plus 1 minus n divided by here I will write instead of writing here. So this will become what? N plus 1 minus n divided by n. This n will get cancelled. This equation will become 1 upon n, and this will become 2 minus 1 upon n. Okay. So now this constant in 0, if you go transport this is origin constant, 0 divided by constant will become again 0. Therefore, this will become 0, and what we have to do? This we have to bring to this side, so it will become plus. So 2 upon n into p2 upon p1 raised to 2 minus n upon n is equal to n plus 1 upon n into p2 upon p1 raised to 1 upon n. This n and n will get cancelled. So finally, what we are getting now? P2 upon P1 terms will bring together. So P2 upon P1 here we will bring together. This will become divided and this will become minus. So 2 minus n upon n minus 1 upon n is equal to n plus 1 upon 2. Therefore, P2 upon P1 will become 1 minus n. So this will become 2 minus 1 means 1 minus n upon n is equal to n plus 1 divided by 2. Only all are mathematical adjustments and mathematics. Everything understood as it is equal to 0. Therefore, all things we are considering as a constant. Understood? Yes, Mita. Others, please reply if anybody having doubt. So all steps I have written so one by one, so that everything will be in means no direct steps, not a single step I have written directly. So understood and write with understanding. Understood or only ask me as understanding, others please reply. Because this is derivation part I am teaching online, but here it is depends on you also, their concentration at the same time. Concentration and only concentration can help you. If you are not concentrating, Prerna one could also yes, understanding, good. Others please reply. Others Jagannath, others Ganesh Gauli, those are giving answers. Please reply and write with understanding. Ganesh Gauli understanding. Good. Good Ganesh. But reply. Others, girls, Dipali Gore, Bhosle, Dipali Gore is attending. Saudi Bhosle, not. Malkilare only once replied, afterwards not replying. Means afterwards not understanding. Everybody have to reply. Write down P2 upon P1. What is the here? P2 upon P1 raised to 1 minus n upon n is equal to n plus 1 divided by 2. after completion, please reply, complete it, reply your whatever message. Okay, others please reply. Ganesh Gauri, Jagannath Patel. So finally solving this equation in class on board. Lot of enjoyment was there because too much lengthy and too much not that much critical but too much lengthy derivation. Bhargav, anybody? Bhargav Dake? Anything? Any question? Okay. Now what we are getting? P2 upon P1 raised to 2 minus n upon n is equal to n plus 2. Sorry, P2 upon P1 raised to 1 minus n upon n is equal to n plus 2. N minus 1. Now what we have done here? So P2 upon P1. So what we are doing is P2 upon P1 so is equal to minus. So this will I calculate this as minus comma. So I will write P2 upon P1 raised to minus I will take common minus what will be there n minus 1 because minus 1 n minus 1 upon n is equal to n plus 1 divided by. Now if I want to make it as a reciprocal of this indexing. So if I want to give the negative indexing, I want to make positive, so it will automatically, this side will become reciprocal of this. Okay, so this will become, therefore this it will become n plus 1 divided by 2. So there this will become p2 upon p1 raised to, if I want to give this minus sign cancellation, this will become reciprocal. So n2 upon, or this will become 1, so this will become our minus here. If I want to give minus indexing, so I can give minus indexing square root like this. So my minus sign for minus 1, if I multiply, then it will become minus 1, and this will become 2 upon n plus 1. So this is mathematical adjustment. So p2 upon p1 raised to raised to n minus 1 upon n is equal to 2 upon n plus 1. So this simple, but understood. Okay. So others please reply. Therefore, p2 upon p1 is equal to, here this will become n2 upon n plus 1 raised to n upon n minus 1. So p2 upon p1, this is here n2 upon n plus 1 raised to n upon n minus 1. This is the final critical pressure ratio. So this is the condition for maximum discharge. This is the condition for maximum discharge. P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. Now, these two steps write down. Understand mathematical, all are mathematical adjustment, mathematical indexing laws, etc. were to apply. As you are giving M3 this time or next time? M3 not there, no? This time I think, maybe I think last time, next time. But M1, M2 given. Am I right? M3 next time, na? Somebody can reply. This is very, yes, next time. Okay, so P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. This is the critical, this ratio is called as critical ratio, where we are getting now, this is the condition for maximum discharge, and this is the critical pressure ratio. So this is the above equation of P2 upon P1 gives maximum velocity or maximum discharge, and hence it is called as critical pressure ratio. We have defined critical pressure ratio as a pressure ratio which will give maximum mass flow rate. This is the value of critical pressure ratio. Now, P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. Write down these two steps. This also write down the above equation of P2 upon P1 gives maximum velocity or maximum discharge, and hence it is called as critical pressure ratio. Now, this MCQ type questions. This is everything is what required for MCQ. These two MCQs here we are getting. So this is also one of the MCQ. Critical pressure ratio value is given by P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. This is equals to one of the equation, critical pressure ratio equation. Written up to this, you can write, tell me over. Now we know the value of superheated steam, n value is 1.3. If you put this value of n is equal to 1.3, so this critical pressure ratio for superheated steam will become 0.546, And this if critical pressure ratio for dry and saturated steam where n is equal to 1.135, it will become 0.855, 0.85, or at least 2 digits, it is 0.58. So these are the two MCQs. So critical pressure ratio for superheated steam is equal to, where n is equal to 1.3, this will be 0.546, and critical pressure ratio for dry and saturated steam, n is equal to 1.135 is equal to 0.85. Sorry, 0.58. This you understand. So we have to put this critical pressure ratio is equal to 2 upon n plus 1 raised to n upon n minus 1. So n value we have to put for superheated steam it is 1.3, and for dry and saturated steam it is 1.135. So after putting substituting that values, we will get the pressure ratio, critical pressure ratio for superheated steam as 0.546, and for dry and saturated steam it is 0.58. For wet steam, we need to calculate the dryness fraction. Also, we add respect to dryness fraction. Also, we should know. So, dryness fraction and n value will decide the n value, because n, if you know, then only we can calculate. And for a dryness, depends on dryness fraction, and wet steam having dryness fraction from in between 0 to 1. Understand up to this? Okay, up to critical pressure values. Please mention and write down also. If it is over, then tell over. Okay, thank you. Understood and over. Understood, yes sir. And understood and over. Others please reply so that I will go to next part. Over. Now this value. So now we have to put the value. Thank you, Ganesh. Okay, this value of P2 upon P1 will give the value of for maximum velocity or maximum discharge. And general equation of velocity we know, and general equation for maximum mass purity we know. Therefore, my velocity equation, the velocity of steam through the nozzle is given by C2 is equal to 2 square root of 2 upon n minus n 2 upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. So for getting maximum velocity, C max, now this will be, now if you put the condition of P2 upon P1 in this equation, let this equation may be fourth equation, I will just consider. Okay. Yes, your sequence, it is fourth equation. So this is, if already it is there. So C2 is equal to 2 upon square root of 2 upon, this already we have derived. Okay. By considering the equation C2 square minus C1 square upon 2 is equal to n upon n minus 1 into bracket P1 V1 minus P2 V2, and by simplifying it we got this equation. Okay, and afterwards we got the mass purity equation from this C2. So we have to put the P2 upon P1 value as 2 upon n plus 1 raised to n upon n minus 1. We put in this equation, then we will here getting C max. Also condition for maximum discharge is here P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. So if you put this in equation, so what we will do? So write down. So we'll put and then we'll write down. Therefore, C2 will become now C max, because we are putting the condition for maximum velocity. So therefore, C max is equal to 2 square root of 2 upon n minus 1 P1 U1 into 1 minus P2 upon P1. Now it will become 2 upon n plus 1 raised to n upon n minus 1 into n minus 1 upon n. This will become C max is equal to 2n upon n minus 1 P1 V1 into bracket 1 minus. So this will become, so this is, I think, okay. So this is n upon n minus 1 upon n is multiplied for only P2 upon P1. So this understand. Here something is here. So here it will make it as a curly bracket. So that So this will become what? 2 Cmax is equal to up to n upon n minus 1 P1 V1 into 1 minus 2 upon n plus 1 raised to now. This will become this and this will get cancelled. Only it will become what? 1 minus 2 upon n plus 1. So it is raised to 1. Okay. But Cmax is equal to up into n upon n minus 1 P1 V1 into bracket n plus 1 minus 2 divided by n plus 1. And this will become n minus 1 divided by n plus 1. Therefore, Cmax is equal to square root of 2 n upon n minus 1 P1 V1 into bracket n minus 1 upon n plus 1. This n minus 1 and this n minus 1 will also get cancelled. This will become 2 into bracket n upon n plus 1 P1 V1. So everything is mathematical adjustments and simplification. So everybody understands Cmax is equal to square root of 2 into n upon n plus 1 into P1 V1. So afterwards, I want that this derivation should be solved and should be submitted to me as today's homework after this. Because this is practice is required for writing this. You write down the critical pressure ratio for wet steam. This also you write down this. And I will not submit the notes till you will submit this homework to me. Because I am, if I have to read and I have to write, so we would have complete this chapter within 1 or 2 hours only. I'm giving time to write you because so that you will understand. It is not the online lecture. It should. I'm just reading, just stay here, showing you slides and completing. Okay, now critical pressure. Understand up to last steps. Only all mathematical adjustments are there. So Cmax is equal to square root of 2 n upon n plus 1 into P1 V1. Please reply. Understood. Okay. Need understanding. Others please reply. Doubts are there. Please ask. Okay. Now this over first page over substitution. Yes, sir. Okay. Prerna is understanding. Others please reply. So first step page over, then write down. But we have to go for next page or put in that case and simplify it. So Cmax C2 will become Cmax when we put the condition for maximum discharge. You write down the equation for C air velocity through the nozzle is given by C2 is equal to square root of 2 upon 2 n upon n minus 1 P1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. Put the equation value of P2 upon P1. Afterwards, I think this page may be over. Not only 2 steps are there. This so for second page. One more big derivation we have to go for. After writing everything, you write mention over and understood. Those have not mentioned earlier understand message, so they can write both messages here, over and understand, or understood and over, whatever you feel. or somebody is commenting. Or please reply. Others, please reply. Okay, now up to maximum velocity we got. Now there is again one challenging, that is maximum discharge to nozzle. So discharge equation we know. So in the discharge equation we got no condition for maximum discharge, and same way we have to repeat that condition maximum discharge to nozzle. So it will be M max. It will be M will be called as M max. So the discharge of mass flow rate through nozzle is given by M is equal to already right is equal to A2 into square root of 2n upon n minus 1 P1 upon E1 raised to P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n plus 1 upon n. This equation earlier we have resolved. We are knowing this equation by putting m is equal to what? A2 C2. This is earlier statement by V2. In V2 we have put as a P2 upon P1 raised to that we have learned what. Okay, and from this now we final steps of that equation was A2 here m is equal to A2 into square root of 2n upon n minus 1 P1 upon V1 into P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n plus 1 upon n. So this we have here solved up with this. Now again now critical pressure ratio value we know P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. So this value of P2 upon P1 now similar here also we have to substitute and we have to simplify it. And then we'll get after simplification m will become what? M max. M will become M max. Okay. So this put you write down these two steps and m equation and putting we here critical pressure ratio value as a 2 upon n plus 1 raised to n upon 1 in this equation. Then maximum discharge will get equation for maximum discharge in terms of pressure and adiabatic index. Please write this idea. There is no understanding to write down. If it is over. Again, sir, I am giving you notes, but still here I want that everybody should write with me so that मराठीत म्हणतो आपण प्रॅक्टिस काय हाताखालने गेली तर बरं असते त्यासाठी आपण practice for making practice and also you have to write once again as a homework and you have to submit it to me after this lecture. You today or tomorrow you submit within 1 hour, not today. Today tomorrow also you submit. After tomorrow you have to submit it. Only 3-4 students now that test I am good response I have got it last test, but whatever homeworks I am giving only 3 to 4 students only submitting to me. I don't know why others are not taking interest. Everybody have to take interest and everybody have to submit. Okay, so m is equal to m max. So if it is over, so this up to this m is equal to this equation and m is equal to then m max will be after putting the value we will get m max P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. Over, please mention. Maybe you understand only writing. So Asmita and yes sir over. Asmita and Prerna only I think they are writing. Others please reply. Now if you substitute this will become m max. M max will become what? Only P2 upon P1 we have to substitute as a 2 upon n plus 1 raised to n upon n minus 1. Now this equation will become concentrate. M max is equal to A2 into square root of 2 into n upon n minus 1 minus p1 v1, okay, p1 upon v1 into square bracket only p2 upon p1, we have to put as 2 upon n plus 1 raised to n upon n minus 1 raised to 2 upon n minus here 2 upon n plus 1 raised to n upon n minus 1 raised to n plus 1 divided by n minus 1 divided by n plus 1 divided by n. So this raised to n plus 1 divided by n. Okay. Now the simplification, m max is equal to a2 into 2 into n upon n minus 1. This is n, not n. Okay, 2n upon n v1 v1 into 2 upon n plus 1. So this n and this n will get cancelled. So this will become 2 upon n minus 1. So there is no problem for this. But this will be 2 upon n plus 1 raised to n upon n minus 1 raised to n plus 1 divided by n. So this will become n and n will get cancelled. And here n plus 1 divided by n minus 1. Okay, and these two steps, okay. So not scratching. Okay. Now here what we are doing is m max is equal to 2 up into n upon n minus 1 p1 upon v1 into now 2 upon, okay, so this 2 upon 2 divided by n plus 1 raised to n plus 1 divided by n minus 1 will take common. Okay, and in bracket it will become what? Here it will be 2 upon, this will bring to this side, and this will become, this will be 2 upon n plus 1, this will become 1, okay, minus this will become, or this, okay, okay, so they have taken this, so this n, this will become n 2 upon n plus 1 raised to 2 upon n minus 1 minus n plus 1, n plus 1 divided by n minus 1. So this n plus 1 n plus 1, as it is minus sign is there, n plus 1 divided by n minus 1. Okay, minus 1. So minus 1 means this side. Okay, therefore 2 upon n minus 1 p1 v1 into 2 upon n plus 1 raised to n plus 1 divided by n minus 1 into 2 upon n plus 1 raised to, this n minus 1 will be common. Okay, n minus 1, 2 minus n minus 1 minus 1, and this will become what? 2 of a2 into bracket 2 into n upon n minus 1 p1 v1 into bracket 2 upon n plus 1 as common. Only here simplification, 2 upon n plus 1 raised to 1 minus n divided by n minus 1 minus 1. Okay, and m max is equal to a2 into bracket 2a upon 2n upon n minus 1 p1 upon v1 into 2n, this is common. So 2 into n upon plus 1. So this minus we have taken one common. So this will become n minus 1 upon n minus 1 minus 1. This n minus 1 will get cancelled. So this will become m max is equal to a2 into bracket 2n upon n minus 1 p1 v1 into bracket 2 upon n plus 1 raised to n plus 1 divided by n minus 1 into square bracket. So this will become minus 1. Minus 1 means what? Here n plus 1 divided by 2 minus 1. Okay. So this afterward simplification, m max is equal to a2 into 2n upon n minus 1 p1 upon v1 2 upon n plus 1 raised to n minus plus 1 upon n minus 1 minus, this will become what? 2n plus 1. So this will become n plus 1 minus 2 divided by 2, n plus 1 minus 2. So this will become, this bracket will become n minus 1 divided by 2. So this will become n plus 1 minus 2, n minus 1 divided by 2, and this 2 will get cancelled, n minus 1 will get cancelled. So this will cancel, then this will become m max equal to a2 throat area into n into p1 upon v1 raised to 2 upon n plus 1, 2 upon, so this n minus 1 and this n minus 1 will get cancelled. So 2 upon n plus 1 raised to n plus 1 divided by n minus 1. From a big equation, maximum discharge of steam through can be calculated. So this is, I think, only thing understanding problem is there where we have taken common, I think, correct? No? So a2 into bracket 2n upon n minus 1 p1 v1 into bracket 2 upon n plus 1 raised to n plus 1 divided by n minus 1. We have taken common, and this will become 1. So minus 1 is there, okay, already. So 2 upon n plus 1 raised to n upon, here it will be n upon n minus 1 into reciprocal of this will become what? Minus n minus 1 this divided by n plus 1. Okay, so this will be there, and therefore this will be, if you do this minus sign here, or this will become this is minus n. So this is, if you view this as a, this will become minus n minus plus 1 divided by n minus n plus 1. If I want to do this as a minus here sign, this will become minus, so this will be
सर डिनॉमिनेटरला n मायनस 1 येते.
डिनॉमिनेटरला
n मायनस 1 येते.
n minus 1. म्हणजे मायनस 1 इथून आपण कॉमन काढलं तर बरोबर आहे ना, बरोबर आहे, स्टेप्स बरोबर आहे, समजते नाही. डिनॉमिनेटरला n minus 1च आहे, बरोबर आहे, इथे n minus 1 आहे, पण इथे n plus 1, इथं समजा minus 1 पण आपण गुणलं तर पण इथे 1 minus 3 येते. एक मिनिट, फक्त ही स्टेप्स मला थोडी कन्फ्युजन वाटते इथली, तुम्हाला समजायला. 2 आपण कॉमन काढलं, 2 upon n plus 1 raised to 2 upon n minus 1. ओके, n आपण 2 हा काय केला आपण 2n plus 1 आपण, ह्याच्यामध्ये काय फरक नाही होणार, आणि मायनस ह्याचा रेसिप्रोकल होणार तो, याचा रेसिप्रोकल म्हणजे त्याचा n minus 1 चा सॉरी मायनस साइनची गरज नाही, मायनस म्हणजे याच्यापासून मायनस n minus n minus 1 divided by n plus 1. हे बघ की स्टेप मी दोन नंतर सांगतो, बाकीचं आय थिंक नो प्रॉब्लेम असा. ओके, understood? I think only that step is only little bit here. Write down with this. Understand? Please mention. ओके, हे आपण स्टेप्स काढल्यामुळे बरोबर मायनस वनच राहणार इथं, बरोबर. सॉरी, इथं मायनस आपण स्टेप्स कॉमन काढलेली स्टेप्स आहेत तिथं आहे असंच मायनस इंडेक्स, त्यामुळे आपल्याला आहे असा स्टेप्सला बरोबर 1 + 1 डिवाइड बाय n - 1 आहे अशी स्टेप ठेवायला लागणार इथं. सॉरी, इथं -1 घ्यायची गरज नाही. सॉरी, स्टेप्स डायरेक्टली इथं कॉमन घेतो ती इथं n - 1च राहणार जे आपण कॉमन घेतो इथे, कारण इथं डिनॉमिनेटर भागाकार जाणार, भागायला जाणार आणि भागितले गेल्यानंतर त्याचा भागाकार म्हणजे समान घातांक असल्यानंतर भागाकार म्हणजे त्याची घातांकाची वजाबाकी तेवढंच होणार. इथं न्यूमरेटर डिनॉमिनेटर n - 1च राहणार, फक्त इथला न्यूमरेटर फक्त -n आणि +1च पुन्हा काय होणार -1. अंडरस्टँड? इथं न्यूमरेटर डिनॉमिनेटर फक्त कॉमनच राहणार. Okay, understand? Please mention and write down. Asmita, understood clearly? Please mention. Not confused like me, like little bit. Jagannath, Ganesh, please reply. Write down everything. Could you repeat the derivation in next lecture? Okay. No problem. As usual, we are repeating. No problem, Asmita. We will repeat. Anything you configured? What where you are configured? Only simple mathematical steps are there. We'll repeat, no problem. So definitely revision always we are repeating. So today we'll stop, I think, with this big derivation. Make practice. I think mathematics, this is basic is understandable. Only thing is there that little bit practice we have to make, and some mathematics